So if you are given a question to do it electrical circuits and you're supposed to find the combined resistance, what you are going to do, you are going to check whether the resistors are connected in series or resistors are connected in parallel. So in this case, if you can notice here, this resistor that we have here and this resistor that we have at this point, the two resistors are connected in parallel. So this is the resistor and the lamp. So meaning that for you to work out combined resistance, it will be 1 over 0.2 over 1 over 0.3 raised to power negative 1, because these two are in parallel. Then you are going to add this one, which is in series. And if you work it out, you're going to get 0.32 as the total combined resistance for this. The next one we have is two resistors here which are parallel, two resistors here which are in series. Then we are going to add these two together, and if you combine these two, you are going to get 12 ohms. Then that 12 is in parallel to this one, so meaning we are going to say 1 over 12 plus 1 over 6 raised to negative 1. If you work it out, you are going to get it as 4 ohms. So we have 4 ohms as the total resistance for this particular connection. Describe in terms of particles how a rod becomes negatively charged. Remember, a material becomes negatively charged if it gains electrons. So the rod must have gained electrons from a woolen cloth. So meaning if you are taking a material, like for instance, I have this material here, and I rub a plastic rod against it. If I rub like that, it means due to frictions, electrons will be transferred. And if electrons are transferred from the woolen cloth to the plastic becomes negatively charged and the woolen cloth becomes positively charged. So anytime you are doing question to do with charging materials, remember materials are charged due to friction, and where electrons are transferred to, that material becomes negatively charged, and those materials which lose electrons, they become positively charged. We have a conducting ball is at rest on the table. When the rod is brought close to the ball, the rod is negatively charged, so the conducting rod is having positive and negative charges. Now since it's neutral, it means that it's going to be attracted to the rod, and the moment this ball is going to touch the rod, then it's going to lose the negative charge, it's going to lose the positive charge. Now it becomes what? Negatively charged, and then it's going to be repelled. So the rod attracts the ball because unlike charges attract, but it's going to be repelled. It will be repelled because when the ball touches the negative rod, it becomes negatively charged, then it is going to be repelled from there. Let's look at the law of electrostatics. If you are told to state the law of electrostatics, what are you going to say as a physics student? How does the law of electrostatics state? The law of electrostatics states that unlike charges attract, unlike charges repel. So unlike charges attract, like charges repel. That is how the law of electrostatics states. So in the event you are told in other exams to state how the law states, that's exactly what you're going to say. Plastic rod is rubbed with cloth, the plastic rod becomes negatively charged and the cloth becomes positively charged. Explain why. So we're going to say due to friction, due to friction, electrons will be transferred from the cloth to the plastic rod. And if electrons have been transferred from the cloth to the plastic rod, the rod becomes negatively charged, and the cloth becomes positively charged. Yeah, so upon doing that, we'll be able to ascertain that now we have explained, or we have stated, why the cloth become positively charged. State what happens to the, now a negatively charged plastic rod is suspended by insulating thread. Another negatively plastic rod is brought close to the suspended rod. So meaning that if you have a suspended rod and this rod is having a negative charge, if you bring close to it another negative charge, it means they are going to repel. So this suspended rod is going to move away. It's going to move away. So the suspended rod will move away. It will be repelled, in case that to be repelled, because like charges repel. Next, we are supposed to define what we mean by the term kilowatt hour. Transferred in 1 hour at the rate of 1 kilowatt. Yeah, so we are going to define kilowatt hour as the energy transferred in 1 hour at the rate of 1 kilowatts. So is are writing in kilowatt hour, so we are going to multiply this by the time we have here, 220, then divide by 1000 because it's in kilowatt hour. So that is going to be, if we put that in the calculator, we shall have 25 and 220 over 1000, and that translates to 5.5 kilowatt hour. Calculate the current in the lamp. We know power is equals to IV. So if we come up with a triangle formula, power is current times voltage. So which means that in this case, current will be equals to power over voltage. So if we cover that, we are going to remain with power over voltage, and that is going to be what? If we work it out, we shall have current is going to be the power, which is 25 watts, divided by the voltage, which was 230. So if we divide this using our calculator, let's check what we are going to have. 25 divided by 230, and that becomes 0.1111 amperes. 0.11 amperes as the current. As the current here. So anytime you're going to be given question to do with electricity, electrostatics, remember some of this concept, because those are the areas that you really ought to know. And then we are having here, as you are going to do your exam for the May-June papers, you may be asked a question that looks like this, and you suggest why a pull code is saver. The user cannot get an electric shock. Yeah, so there's this pull cord. The person can pull, in the process want to turn on the electric fan heater, because this is made of an insulator. The cord is made of an insulator, insulating material. Then this person cannot get electrocuted or cannot be able to get electric shock. Now we were supposed to say the components. Name the component X. Component X here, you can see there's a line, thin line across, and now this becomes what? A fuse. A fuse is an electrical device that breaks a circuit when there is a excess current flowing. Component Y, you can see here is M, that is a motor. And we have a heater at this given point. So you really need to understand different components, electrical components, as far as electricity is concerned. Calculate the current. You can see the power is 2000 and the voltage supply on this device is 230. So meaning current is equals to power over voltage, which is going to be 2000 watts divided by 230. And if you work it out, you are going to get 2000 over 230. That translates to 8.7 amperes as the answer for this particular case. So in the event you are given a question, you are really expected to show all your working and make sure you give your answer. Don't give your answer as fractions. In physics, we don't give answers of fractions. Yeah. So under electricity connection, different resistors, you can see here we are having what? We are having connected. So if we are having this kind of resistors connection, what you need to remember is that you need to know when they are connected in series, what you do. When they are connected in parallel, what you are supposed to do. Here, these two are in series. So when they are in series, to calculate the combined resistance, you just add R1 plus R2. So this is going to be 20 plus 40, and that is going to translate to 60 ohms. That is the total resistance. In part B, we are told two resistors in the figure that we have here are connected to an ammeter and a 12-volt battery as shown. Yeah. Then once you've worked out that, you're supposed to calculate the potential difference across the 20 ohm resistor. We're supposed to work out the PD across the 20 ohm resistor, but we understand total resistance is 60 ohms. So current that is going to flow is going to be voltage over resistance. Voltage divided by what? Resistance. So in this case, our voltage is going to be what? Our voltage is 12 volts. And our resistance is 60. So if you work it out, let me just look for a different pen. concede this pen has run out. Let me check if this can be able to be feasible. Yeah. So if we are having that, we're going to put that in the calc, because the total resistance of this circuit is this plus this 60. Then the voltage is 12 volts. Then to get the current is voltage over resistance. This is going to be 12 over 60. And that is going to translate to 0 0.2. 0 0.2. And since this circuit is in series, then we are going to say current that is going to pass here is 0 0.2. Current that is going to pass here is also 0 0.2. For a series circuit, current is the same throughout. So which means that if we want to work out PD across 20 ohm resistor, V is equals to IR. So meaning current is 0 0.2 times the resistance of 20. And that is going, yeah, not 0 0.4 but 4 volts. Yeah, so need to ensure that I don't mix up. So if you work it out, you're going to get 4 volts there. A student used a voltmeter to measure the PD across the 20 ohm resistor. Draw on the figure here how a voltmeter should be connected. How a voltmeter should be connected. So we are going to say a voltmeter will be connected like that. Should be connected in parallel, because it's a high resistance device. Now, suggest the combined resistance. For this, we're going to say 1 over 20 plus 1 over 40 when they are in parallel, raised to power -1. So anytime you add them like this, you have to find the reciprocal to get the total resistance. So we are going to say 1 over 20 plus 1 over 40 raised to power -1. And if you work it out, that is going to translate to 40 over 3, which is approximately